Okay.
All right. All right, let me know when you get caught up there on getting your data entered.
Okay.
It is worth double checking that you've gotten all the data.
Mhm.
Okay, so you got that going all in
Yes.
there. All right. So the next thing is actually to go to stat calc. And I'll write this down on your notes. Stat, and then calc, and then one variable statistics. Now in yours, you probably can choose list 1 or list 2. If on this screen, I'm just going to have to type in list 1. But make sure you've chosen list 1. I think you hit OK on yours. And it gives you all this stuff here. What do you actually want? You actually want, you have to hit the down arrow, you actually want the min, Q1, the median, Q3, and the max. That's called a 5-number summary. Do you remember that from class?
Mhm.
Okay. So let me actually just grab those. I'm going to do a snip on my side, and then we want to do the same thing with the other one, the fertilized plants. So you're going to want to get those numbers down. I'm going to quit. I'm sorry, second quit. Oh, I don't need to quit out of that. All right. So you go to the same place. Instead of L2 though, or instead of L1, I'm going to choose L2. You hit enter again, and you get those data points here. So let me grab those, and then we'll talk about how to actually make a box plot. But this just shortens up the time to do it.
Okay.
So any questions on that? Because I do need to move to back to the other screen away from this one.
How did you switch from L1, or do you just go to
When
variable stats?
no, you do one variable stats, but you have to actually choose L2. So
Okay.
on your screen, it probably by default says L1, and then in terms of where is L2, L2 is under number 2. It's the second L2.
Okay.
All right, can we move, did you get these numbers? Is that okay? Is that all good so
Yeah.
far? Okay. All right, so let me share the other screen. It's a little cumbersome the way of doing it virtually, but I've got the data's over here. So you actually start with the median. So the median for the first one is 4.65. So I'm just going to draw a vertical line at approximately 4.65. Okay, 4 points somewhere in there. Then you go to Q. So I've taken care of that one. Then you go to Q1. And that's 2.6. So roughly there-ish. Okay, that's not drawn very well. And then you create a box. Q3 5.2, say roughly there. You create another box. Okay. And we can do the same thing for the other one, but we actually need to figure out next if there are any outliers. Okay, and that's where we have to need to find what's called the interquartile range IQR, which is Q3 minus Q1. So 5.2 minus 2.6. Okay, and that is 2.6. And so this thing that's called a lower fence, have you heard that in class?
I don't think so.
Okay. Well, there's the likelihood that there's outliers here, potentially. That's why we're doing this. So, but you got to tell me, like, this is extra work that we don't need to do if you don't think it's going to be part of your quiz.
I actually think it will.
Okay. So the lower fence is Q1 minus 1.5 times the IQR.
Oh yeah, okay.
Okay, and it's a little bit of work here to calculate, but that's what it is. So it's 2.6 minus 1.5 times, in this case, it's 2.6 again. All right, and that's minus 1.3. You also need the upper fence. The upper fence is really similar. It's Q3 plus 1.5 times the IQR. And so you calculate that as well. Yeah, yes, there's a lot of calculations in this, and that's 9.1. So the reason you do that is if there are outliers, which there are not, and I'll say why in a moment. If there are outliers, it affects how you draw this. Okay, but you go look at your data set. The min is 1.9. 1.9 is greater than minus 1.3. So there's nothing below minus 1.3. 9.1 is this upper fence. The max is 5.9. So you're fine. So to finish this drawing off, you go to your min, which is 1.9, and you put sort of a smaller line. And that's the whisker. And then 5.9 is over here somewhere, a smaller line. Like that. So the idea is it's box and then these two whiskers coming out.
Okay.
So like generally, but not always, that's Q1, that's Q2, that's the median, that's Q3, and that's Q4, the max. Actually, these are better. Say min and max. Any questions on that?
Not so far.
Okay, so the same thing is needed on the one on the right here. So you start with the median, 3.35. You put and for our purposes, try to make them the same height. So there's 3.35 roughly. Q1 is at 3. So you make your first kind of box. Q3 is at 6.2. Whoa, way over there. And then again, the next thing is you need to calculate this interquartile range IQR. So your IQR 6.2 minus 3, which is 3.2. And then your lower fence is Q1, which is 3, minus 1.5 times 3.2.
Okay.
And that's minus 1.8. And there's no values smaller than minus 1.8. So you're good on that. Your upper fence is Q3, 6.2 plus 1.5 times the interquartile range. Do you have, I don't know if you're calculating that, but no, let me calculate for yours. It's 11. 11's bigger than that. So what we're looking for, like, let's say the data set had a number like 12 in it, then you know there would be an outlier because it's above that. Okay, so, but we don't have that in this case, so we're gonna graph the min. The min is 2.3, so a little smaller line there, and then the max is 7.3. I don't know, it's about there. All right. Okay, now let me go back to the calculator, and I mean, I think this is awesome that the calculator does this for you, but I don't know if it's been taught. It's good to have because you can just make sure it looks right. So you're going to go to second stat plot.
Okay.
And this plot 1, we're going to hit enter on it. And if you see, so we have to turn it on. It's currently off. So you have to hit enter there, and then type. This is really important here. You want the type that's a box of whisker. Now there's 2. I don't know why there's 2, honestly. Let me actually do a quick check of why there's 2, because I don't know why there's 2 there. So they choose the one on the left, which is the one I was going to mention, but I was sort of, okay. And then you have to choose L1. Okay. You can do that. Now, what's kind of cool here is you can also do plot 2. So you can actually go to plot 2, hit enter on that one, turn it to on, do the same thing, go select that box plot, and then change that one to L2.
How do you change it from L1 to L2?
You have to hit second, and then the number 2 to get L2.
Okay.
All right, and then when you're ready, you can go ahead and hit graph. Now we might have to do a zoom stat, but we'll just try it. Yeah, so there it is. And it's really similar to what we did as well. So I think, I don't know, that maybe that's neat. I mean, it was when these calculators first came out, but maybe now it's kind of, but any questions on that? Because that is something you might want to do.
Not so far.
Okay, now there's a lot of build up to being able to answer the questions here. So I'm going to go back. All right, let me go back to that. New share. Okay, so it looks pretty similar. Now, the next thing it kind of wants to talk about, I believe, is it's going to ask you things like the shape and stuff like that. So let me go pull those questions up so we can answer them together. Yeah, so it wants to know about the shape, the center, outliers, spread. Okay, here we go. Okay, the shape. So there's two types of shapes here. So this one on this top one, if I were to draw a normal curve over this, and really this, I mean, this comes later in the course, the most of the tail is going to be, it's like that, and then it's really short here. Okay. And then the one on the bottom, if I were by comparison, it falls off pretty quick here, but it's got a much longer on that side. All right, so this one on the top is called left tail, and the one on the bottom is called right tail. And it's really meant to mimic, like, if you think of an animal, a cat, probably the best example of their tails sort of flowing down into the right. So in terms of shape, that's what we're answering. So you have to be specific. You have to say the unfertilized is left-tailed, unfertilized, left-tailed, and the fertilized is right-tailed.
Okay.
Sometimes they're really asking for a comparison between the two.
Mm-hmm.
And I'm not sure here, but we'll just, we'll go with that. Okay, now the center is always the median. Okay, but there's also kind of these words that they use. And this is where I need to know a little bit more about your class. Like sometimes they want to know whether the mean is greater than the median or it's less than the median, but they're referring to the median. And so you want to say that the unfertilized median, or average, or center, not average, center, is a 4.65.
Okay.
It's actually kind of surprising. Is that really right? Yeah, I guess it is. Okay, and then the fertilized is 3.35. So the center is actually higher for the unfertilized, which I'm actually surprised by that. There are no outliers in this case. That's what the whole business about the upper fence and lower fence.
Wait, so why are there no outliers?
There were no values above or below the fences that we calculated. That's where the outliers would show up. And then in that graph, there was no outliers either, like that confirmed.
Oh, okay.
Like if we do an example with outliers, it'll make sense. But until we do one, it's just, it doesn't really help here.
Okay.
But like I'm trying to like talk about all the cases, and really we would need to do like 2 or 3 a bunch of examples.
Okay.
Okay, now in terms of spread, Sometimes they're talking about the shape, but really they're looking at like the width of this, the max minus the min.
Mhm.
And notice like you're looking for the one that's wider. So the fertilized looks to be wider to me, like wherever the max minus the min goes.
Okay. So it's like it's the range.
Yeah, I mean, it's not a great answer, but yes, we could think of it as the range, the max minus the min. So in true statistics, there's a lot of a ton of like gray zone. And it's a really interesting topic. It's covered in social science, traditional sciences, engineering, but you get kind of a range of like ideas, opinions about how to kind of talk about these things. So that's why it's a little hard for me to be more direct about some of this stuff, because it really depends on what your teacher says on there. Now for me, this next question is the most important like thing that comes as a result of working this problem. It's like now that you see the data, you've done some analysis on it. Should you use fertilizer or not? And that's where you're supposed to interpret. And for math students, that's always tough. Interpret means write a sentence or two. So let's go back and look at the graphs. The unfertilized has a higher average, but you could also have really a bad output. But it's really not that different than this, in terms of like the mins.
Mhm.
You definitely get a higher ceiling with the fertilized, like meaning like you could get a lot more out of it.
Mhm.
So that's the kind of things that they're looking for. There's not necessarily like a right or a wrong answer. You give an answer and you properly justify it.
Okay.
Okay, so we've kind of talked to death about this first question. Are we going to spend the 2 hours on this topic?
Um.
Stats, or was there something else you want to do the second hour?
Yeah, it's just this.
Just this. Okay, so we're going at the pace we're going at is fine. I think it would be good to do another box and whisker plot problem, but maybe you've already done the one for P. Maybe not. Okay, I'm not seeing another box and whisker plot. Do you want me to find one, or do you want us just to move through to number 2?
Um. Maybe just number 2.
Okay, let's proceed. All right. The R&D department of ACE Chemicals, who manufacture the fertilizer, is motivated to try out their own experiment. They create a plot of 1,000 fertilized plants and after 1 month obtain the following statistics. So they the mean is you add them up and divide by the number of numbers. The standard deviation is a little bit more sophisticated calculation, so on. Okay, so the question is, if the measuring device wasn't calibrated properly, all the measurements are shortened by 0.5 centimeters. How will the mean and the standard deviation be affected? All right, so it's sometimes it's easier. Let me just do it this way. Let's do 1, 2, 3. Let's look at a data set here. 1, 2, and 3. What is the average of this data set?
2.
2. Now to find the standard deviation, let's go, actually, yeah, let's go to your calculator and I'll have you do that part. I want you to clear out list 1 or list 2, or you can go to list 3, but probably just clear out list 1, list 2. And I want you to do that one variable stats for this.
Okay.
And you want the, well, I'll go with that in a moment.
Wait, so after I input all of the values into list 1, what's the second step?
You go to, let me scroll up here and show you so you can see it. I wrote it down here. Stat calc one variable stats.
Okay.
Okay, and you're looking for the one that says SX, big S and then an X. Do you have that number for me?
I got 1.
You got 1, great. Okay, now the next thing is kind of what it's asking for here. Like you can either go into list 2 or go to list 1, but you want to subtract each of these by 0.5. So you can either rewrite the numbers, but your new data set's gonna be 0.5, 1.5, and 2.5. And we're gonna do the same thing. We need to calculate the standard, the mean and the standard deviation.
Okay.
Do you have the new mean and standard deviation for me?
So sorry, just really quick. So you use the 1.5, 2.5.
Yeah, we're just trying to we're changing the data set kind of the same way this problem is by subtracting 0.5 from each data point and seeing if that changes anything.
Okay, so the mean is 1.5.
Okay, I agree with that.
And then I'm a little confused about the standard deviation part. I think I need a refresher on.
It's under one variable stats. You're just going down to the SX under one variable stats.
Okay. Okay. The standard deviation is 1. Oh wait, Matthew, I think you're muted.
All right. Hey, sorry about that. I was asking if you noticed that the measures of the spread, since they're the same, if graphically you see why that is, because 1, 2, and 3 have the same distance between them as 0.5, 1.5, and 2.5.
Okay.
And that's why this is the change. So this little example that we did here, it helps to answer this question, which is that when the data points are adjusted, the mean is changed,
Mhm.
but standard deviation and variance, which is related to this, is not.
Okay.
And that's what you have to remember. Like, that's what you have to take away from all this, is that, hey, you know what? Is that okay?
Yeah.
All right. So like if you were to get a problem on a quiz that says, you know, it was increased by 3, you would say that the mean is changed. It changes by whatever amount this is, but the standard deviation does not.
Okay.
Okay, so let's move on to the next part of this question, which says if 50 plants. Okay. Okay. So let's go. So before we answer this question, the analogous one is the one that we just did. We know that if our data set is 1, 2, 3, our mean is 2, and our standard deviation is 1. Okay, but now they're basically saying we're going to add some to our data set, but they all equal the mean. So like, let's do that in our new data. So let's go 2, 2, 2. Let's add one more, 2, and then 3. So I want you to calculate the new mean and the new standard deviation of this data set. So put that into list 1, variable stats. You're going to get tired of doing this, but you're going to do this over and over again in this course.
The mean is 2 and the standard deviation. Um, 0.63.
Yes. Okay. Now, what do you notice? How did the standard deviation change?
It got smaller.
Got smaller. Okay. And that's the point of this exercise. The point of this exercise is that again, because you're adding points that are equal to the mean does not change.
Okay.
But the standard deviation and the variance, they get smaller. And that's important. They get smaller because there's more data values closer to the mean, which means that there's less like spread.
Okay.
So that if we just briefly go back in this previous example, the mean changed, but the standard deviation did not. And in this second part, the mean did not change, but the standard deviation did.
Mm-hmm.
And there's kind of another variation on this, which is the standard deviation variance could get larger if they do something else, but I don't know if we have time to cover that. But is it kind of clear what's going on?
Mm-hmm. Yeah.
Okay. Okay. All right. So now, okay, number 3 really should have been done before this, but we'll get to it now. All right. The top 20 crime bosses of Gotham held a recruitment ceremony for henchmen. The following data shows the additional henchmen each villain had recruited. Okay, so a lot of words there, but they're saying, hey, this is our data set. And one of the first things that you can do as a statistician or a person that's interested in this data is you just graph it. You're just like, I wonder if it looks like, maybe I noticed something. So I'm going to just carefully mark 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for each data point, you put a dot. So for the 2, I'm going to put a dot right there. 3 has 2 3s, so I'm going to put 2 dots. 4 has 2 4s, so I'm going to put 2 dots. 1 5, 2 6s, 2 7s, 3 8s, 2 3 4 5 6 7 8 9 10. Oh, I'm so sorry. I got off by 1. Luckily, I can do this, clean it up. Okay. And so there's 3 8s, 1, 2, 3. There's 1, 2, 3, 4, 5 9s, 1, 2, 3, 4, 5, and then 2 10s. And you're hoping to see like some sort of a trend here, which this really doesn't do much. Any questions on this?
No.
Okay, so let's move on to the next part, which is a bar graph. So very important bar graph here is that the bars do not touch.
Mm-hmm.
So I'm gonna try to do side by side here. Sorry, I guess I'll do it down here. Okay, so the bars do not touch. So like you would want to, you have one for 2, and you would, what did we say here? Sorry, it's glitching a little bit. There's only a height of 1, so you would, your bar would go up to 1 for that
Mhm.
one. But and for 3, you got 2 3s, so we'll go up to 2 there, something like that. And then 4, there's 2 4s. Okay, and then a 5, there's a 1 5, like that. And then there's 2 6s and 2 7s. But they can't touch. That's really important. I'm saying that over and over again because if they touch, you might get marked off on the thing.
Okay.
And then 8, how many 8s are there? 3 8s. So I have to go build a new height box here, 3 8s. And then 9, there's I think 5 of those, 5 9s, and so on. And what you're going to notice, let me see, there's 2 10s, is that it really has the same shape as the previous one, as the dot plot, but sometimes visually a bar graph is easier. I'll even write that, easier to see than a dot plot.
Mhm.
It's preferred. Like someday you're going to be working somewhere and they're going to want a visualization of the data. So you're going to say, oh, let me make a bar graph. I remember Matthew telling me about that. But you can see that it's basically the same. A computer makes this look a lot nicer.
Okay.
All right, for the other 2 pictures, did you get the data from class?
For the piano project?
For the pinky to length, and then the other one's piano. Yeah.
I did, yes.
Okay. Probably be good to send that over between now and the next lesson so we can do that. It's good that we're doing some more box and whisker plots, things like that. Okay. Can we pause here, or do you have any short questions I can answer in the next couple minutes?
Not really. I think I'm good so far.
All right. Well, I will see you in about 10 minutes.
Okay, bye.
Bye.